Hey guys, what's up? I'm here to teach you about the derivative as a function. So first off, let's have a little bit of review of the definition of a derivative. So a derivative is equal to the slope of the tangent line at a given value. This a little more review of algebraic slope, which is equal to y2 minus y1 over x2 minus x1, or the change in y over the change in x. The derivative, which is equal to the slope of a tangent line at a given point, is change in y over the change in x. So it's equal to the limit as h approaches 0 of f of a plus h minus f of a all over h, where a is a specific given value. But how do we find the derivative of the overall function and rather than just at a specific value? So the way that you do that is by looking at the derivative as a function. So f of a, where a is equal to a value because a is a value, but f of x is a function because x is a function, and h is equal to the change in x. Given that, the change in y over the change in x, or the derivative, is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So given that, if a function is not continuous, is a piecewise function, or is an absolute value function, then it is called not differentiable. So a function, an example of a continuous and differentiable function would be f of x is equal to x squared. So the way that you find the derivative of that is equal to limit as h approaches 0 of x plus h squared minus x squared all over h is equal to the limit as h approaches 0 of x squared plus 2xh minus h squared, plus h squared, minus x squared all over h. Those x's can cancel and so can those h's, so the derivative is equal to the limit as h approaches 0 of 2x plus h, and when you substitute in that 0, then you get 2x, which is the slope of the tangent line over the entire function at any given x value. So an example of when f of x is continuous but not differentiable is an absolute value function, such as f of x is equal to the absolute value of x minus 6. So to do this, you have to break it up into two pieces: x minus 6 when x is greater than or equal to 6, and negative x minus 6, the absolute value as function, when x is less than 6. Then you have to look at the limit of the derivative from both sides. So the limit from the right side is equal to limit as h approaches 0 of x plus h minus 6 over x minus x minus 6 is over x is equal to 1 if x is greater than or equal to 6. But if the limit from the left-hand side is negative x plus h minus 6 minus negative x minus 6 all over h, which is equal to negative 1 if x is less than 6. So because the limits of the derivative from both sides are not equal, then the function is called not differentiable. Some common mistakes people make when trying to find the derivative is that they substitute h for 0 right away rather than doing all of the algebra first. So the limit as h approaches 0 of f of x equals x is equal to x plus h minus x all over h. And people would substitute in 0 over 0, which is generally kind of infinity, but because of that algebra, it's wrong. So the correct way to do that is the limit as h approaches 0 of x plus h minus x over h is to cancel out the x's and just get h over h, which is equal to 1, which is the limit in the derivative. So next is how to find the derivative of a function based on its graph. So if you're given a graph that looks something generally like this, where f of x looks something like that, the first step is to estimate the slope of the tangent line at every given x value. And then the next step is to graph f of x is equal to that slope at every given x value, and that graph is the graph of the derivative. So the derivative graph of that graph would look something like a parabola. A common mistake that people make while finding this is that they get confused and draw a graph that looks very similar to the original function graph. So they would draw something maybe that looks a little bit similar to the graph, the original f of x graph, like this, or like like that. But that's wrong, because the slope of the original graph is increasing, so it's positive and then positive again in the original graph. Then the derivative graph would look something like that. Thank you so much for watching. If you need a little bit more practice and explanation, I have a worksheet that I will link below. I hope this was very useful, and yeah, thank you so much for watching.